the beginning of our lecture while the projector is booting up. So I hope you all have fun with the MIDI assignment. What I want to say is, tell you what, if you're having difficulty with the licensing, I noticed these first 4 row computers, I had put a license on previously, like last year, and like now they won't let you sign up for a trial. So if you're doing your work on one of these 4 computers, and you want to turn it in, and you don't want to lose your work, you can either send me a screenshot, but from that screenshot, I'm going to make sure it works. So don't send me a screenshot saying it doesn't work, because I'm still going to like make it and then, because I can do it real fast. Or you could send me a video of yourself playing with it in QuickTime. How do you do that? Well, all these computers have QuickTime Player on them. I don't know if anyone here is old enough to remember QuickTime, like old school QuickTime. Yeah, it's been around for a minute. This seems to be like its saving grace at this point, is its ability to like screen capture pretty well. So if you just like spotlight search command spacebar, and then you type QuickTime Player, it'll come up. And I already have it running because that's how I'm recording our lectures. And with QuickTime Player, let me go back to it. It'll open up here, and you can hit File and then Movie Recording, which opens up the camera, which these computers don't have a camera. That's the camera mode. And then Screen Recording, which actually records the screen. When it's done, it'll save it to the desktop. And then you can actually turn that in. You can also send me the max patch. So I'm just saying this, like this is a backup. If it, like, it won't save and it's giving you heck, then you can turn it in that way. And then like play around with it and demonstrate to me that it operates in the way that you expect it to. Hello. Okay, so anyway, let me see here. I'm gonna make a new patcher. I have my terminal open because I wasn't sure if my voice was gonna make it today. And so I have my terminal open, like I said, because I wasn't sure if my voice was gonna make it. Just in case I had to, like, I don't know, do the lecture.
Do the lecture from the terminal.
Which I've actually literally had to do before because my voice was like gone. And so I had to like speak from the terminal. You guys know this feature exists, yes? I hope. No? Okay, we're gonna learn something new today. Because actually what we're gonna do is we're gonna make a file. Because, well, this is an easy way to create something a little weird. Let's explore this really fast. All of your computers have a terminal. It won't look as cool as mine because I've made mine look like this, with semi-transparent with green text, very matrixy. You can find the terminal by hitting Command Space and starting to type in terminal, and then you'll have it, and then just hit Enter. And it's going to open up a text window like this. So the terminal is like, how do I say it? People call it a shell. It's a way of interacting with the computer directly with text, rather than using the desktop, the visual, the GUI, right, the graphic user interface. You're actually like typing commands to it. And you can do all kinds of fun things. Like I can ping google.com and I can do that, and it'll like literally send a ping to google.com to let me know that the thing is working. Okay, and then you can always terminate a process by Control-C in the terminal, or you could close the window as well. This class is unfortunately this isn't like a terminal comp sci class right now, but Macintosh computers have this natively in the OS, the ability to type say, and then something. And then it'll interpret that. So we have a nice accessibility feature here.
Something.
There you go. Can it say bad words? Yes, it can. Please don't. Anyway, and so you might be wondering, where can I get more information about how to use this feature? Well, you can type man say. Now, this isn't man say. This is the manual for say. And you type man say, and it'll give you this little pop-up guy, which tells you about some of the options you can do with say. And there's all kinds of stuff. There's different voices. We're going to play with the output in a little bit and make a file, and then bring it into Max and then mess with it, because that's just what's up. There's lots of stuff in here. If you want to get away from this, once you're here, you just hit Q for quit, and it sends you back. Pretty nifty, yeah? Yeah, okay. So anyway, let me, I don't have my windows the way I want to. I have to shrink my face. That's okay. So we can basically put almost anything in there. There are other voices. Let me see if I'm remembering.
Question mark.
No, it's gonna be that. There it is. Okay, I remembered. So if you put say, here, check this out. Do this with me. Check it out. Check it out, because you can play with this. I'm gonna type. I know it's really small down there. Darn, and it's like out of view. Okay, let me adjust this. Sorry, y'all. I was like trying to be fancy with my setup here, but it's not gonna play ball today. Okay, now everyone can see it. Great. So I'm gonna put here. I'm gonna put say, V, and then question mark. And it's gonna spit out a bunch of text. And it's going to, these are all the voices that are available. There you go. So I'm gonna try Jester. So to do Jester, V, Jester, hello. So if you want to change the voice of what you're doing, and by the way, this does relate to what we're doing today in class, so don't worry. I know it seems like we're playing around here, but I count this also as computer literacy. So say -V and then pick one of those names. I'm gonna do Xander. I've used Xander before. I like Xander. Maximum cringe. Here we go.
Bling bling.
There you go. Maximum cringe. What's another one? What up? What do? Anyway, this is fantastic for a number of purposes, especially like thinking about accessibility features for nonverbal folks, things like that. There's ways to communicate here. And if you one day have to lecture or give a presentation and lose your voice, you can actually literally, I've done it, you can teach a whole class from using the say commands. Okay, cool. Now don't close your terminal. We're gonna come back to that in a second. I wanna do some kind of gritty work with Max first and talk about some math and logical operators. And then we're gonna come back and then play with a sound that we make. So I'm in Max. I want you to go ahead and open a Max session. By the way, I've said this before, I'll say it again. If you click on Max or you open Max on your terminal on your computer there and nothing seems to happen, but the little dots down here, it is open, I assure you. Sometimes it won't bring up a window, but you'll click on it, it'll put Max here at the top, and then you hit File, New Patcher. So if it doesn't seem like it's opening, I assure you it's opening. Yes, something. And so you can hit New Patcher. Okay, so we've been playing around just with sonifying data. Y'all know what I mean by sonifying data? Did you watch that little video I made? The words of encouragement video? What do I mean by sonifying data? Any stabbers? Want to take a stab? Et tu, Brute? Anybody? Huh? Making what to sound? Data. Okay. Yes. Data of some kind, and then turning it into sound. I know that seems very simplistic, but what we're actually making are data-driven instruments. And we're going to make some more interesting ones today. What an interesting idea. A data-driven instrument. Weird, man. It's like we're collecting those numbers and then turning them into something that's going to be a little bit useful. What a shame all those numbers are just flying around in the cloud right now, not being sound. What a waste. Anyway, so let's play around with some of the math operators. Let's make an object, and I think we'll see a more discrete purpose for these in a second. I'm going to make this a little bigger. Okay, so I made an object box by hitting N. And then what I'm going to do is I'm going to put a plus. And then I'm going to put an argument. And so I'm going to call it an integer. 12. Great. I'm going to put an integer box on top, integer box below. I'm going to connect the top one to the leftmost inlet, and then the outlet to the bottom integer box. I'm going to lock the patcher, and then I'm going to scroll and play with these numbers right here. And it's adding it. Cool, man. What's up? The middle one. What did I press? Oh, I'm sorry. I pressed the hotkey was N to create an object. You could also go click at the top up here. This little bar up here, if you see my cursor, has stuff for objects. Can we hypothesize what some other mathematical operators would be? Yes, there can be a minus. Minus. And then I'll put an integer 17. It's prime. I like it because it's prime. Cool. And then we can do the same process where we're putting integer here, and then an integer here, and then make sure it works. Yep. Can it do negative numbers? Of course it can. Of course it can. Okay. That's pretty neat. What's another one? Multiply. How do you think we're going to represent that? Not an X. Yeah? The asterisk. An asterisk. That is, hold shift and press 8 on your keyboard to get the asterisk. And then I'm going to put an argument in there, and I'm going to put 1, 2, 3, 4. And it's going to become an astronomical number pretty quickly. And there it is. And it works. It lives. Okay, neat. Another one. Division. How? A slash. Yes. Yep. Okay, so slash, and then I don't know. What's a good prime number? 2. I'm gonna do 3. And then it'll do the whole thing there. Now, by the way, make it a little more interesting. Nope, it's still going to round it. Okay, very well then. Oh, I know why. Silly me. Boop, boop, boop. There it goes. Okay, so while you were watching this, you might have been saying to yourself, hey, wait a minute. You can't divide some of these numbers by 3 and then just get an integer output. So let's talk about this real quick. We've been playing with just integers right now. How do we represent what you and I would call a decimal number? What's the name for that? I've said it a few times. It's an F word. It's a float. It's a float. Now, what I had to do to divide any number by 3, I had to do 2 things. I had to make the output, instead of having I for integer, I hit F for float. And the only difference you see is that you have that little decimal dot there. But that's our floating point. It's how computers handle what we call decimals. And furthermore, I had to make the argument in the box, the argument in the object box, have a dot, have its floating point. You don't need any other numbers after that unless you want them, right? But you do that, and then it'll actually put out, it'll divide this integer by this, and then put out a float. And then you'll get these. It terminates after a certain point, so it doesn't go on forever and crash the computer. Right? Make sense? Pretty rudimentary. Okay, great. Now the reason we have integers and floats, right? Think about your MIDI numbers, MIDI integers. We're just dealing with 128 values, all represented as whole numbers, as integers. But how do you represent frequencies? Everyone knows A at 440, right? But what about the other ones? Here's a hint. They're not just, especially like with equal temperament. I guess you could make a temperament where they're all integers and they're all whole numbers. Great. Okay, sure. That's a different type of tuning system. But in their natural habitat, we would express them in equal temperament as having decimal points, as having float, right? Let's do that. And this is also falling under the heading of mathematical operators. Yeah. Let's make an object called MIDI to frequency. That's M to F. And let's do, let's just send a 60. I'm just going to do a message box. Let's send 60, and then, oops, I want a float output. So I made a float output, MIDI, bomb. And what I'm going to do, y'all, is I'm going to, so I can see all of the numbers. Yeah, I'm sorry, M for message. I should have been louder and clearer with that. M for message. Just because I want to send just one number through when I click on it. And to send it through, I have to lock the pattern and then click on it. And what I also did was I made a float object for the output, and I extended it out here. I dragged it to make it bigger so I could see more of the numbers. So when MIDI says 60, the frequency that comes out is, in hertz, 261.625565. And even then, I have a sneaking suspicion that is that is truncated at a certain point. I'll make another one so we can see. 62. What pitch colloquially is 62? D. I heard D. Yes, it is a D. And I hit D, and then it gives me the frequency number of what is imagined as D in our equal temperament system, which is what MIDI is. Making sense? Okay. Now, we're going to play around with this later. I hope you're already thinking about purposes for this. Can you, wait a minute, can you do frequency to MIDI? Yes. F2M. Sorry, my inner gender scholar is just like screaming right now. So here we go. Frequency in. I'm going to put a float. Boom. And then down here, I'm going to put MIDI number out. You could put a float, but it's not going to have any decimal points. I'm just going to put an integer. And I'm just going to put in some rando float in here. Oops, lock. And what it's going to do is it's going to round it to the nearest MIDI number. How many decimal points can I get? I don't want that. I know there's an option for this. Where are you at? No, I think I'm looking right past it. Okay, so right now, we're converting a frequency to a MIDI note. And you might say, Dr. Welty, it's not changing even though you're changing these numbers over here. And I would say, yeah, because it's rounding. It's rounding. Does that make sense? The MIDI numbers aren't going to round. Why would they? They're not going to do that because they're discrete integers, just whole numbers. Okay. Any questions about this? No? I want to, huh? Yeah.
How does get the numbers to scroll? I'm having issues doing that.
Yeah, what a great question. Thank you for asking that question. I'm sure other people are wondering that too. Okay, so to get the numbers to scroll, what I'm doing is I'm locking the patcher, and I'm being a cool cat about it by hitting Command click somewhere rather than just clicking down here. But once the patcher's locked, I click on this. Notice how it lights up. I'm clicking and dragging up and down on my trackpad. With you, it'd be the mouse where you click, left click, and then drag the mouse. Yeah, you got it. Thank you for asking such an insightful and important question. Now you might be wondering, Dr. Welty, how come you're only using that? How come you're only using that, like, I don't know, left inlet? And I'd say, well, yeah, because I can't make it any bigger, but I can't make that little sample text any bigger. That says set right operand. The left operand was the number going in. The right operand doesn't mean the correct one. It means the right side one is the argument. So you can change the argument. This is just like our metro object, right? When we were changing the argument of the metro object, and it might not look different to us, but it'll be something. Here, let's do this. I'm gonna set this one to 0. Set this one to 0. Just setting it to 0. And let's do 0 minus 5 is indeed -4. True statement. In an age of misinformation, which is just numbers. Okay, so notice that the argument did not change. The important thing too is that, excuse the language, this is Mac's language, okay? I don't mean to be ribald here, but I banged the right inlet first by sending this number through, and then I had to bang the left inlet to get the calculation to go through. That's also, by the way, the difference between if the colors are visible to you, the left inlet is like a little bit of a light red, and the right inlet is a blue, and that's to represent hot and cold. If those colors aren't apparent to you, that's okay. You can remember that the far left will always be the hot inlet that takes a bang and sends it through. Is that a question? Yeah, what's up?
Is like A supposed to move the other numbers when you lock it too, or not?
So, yeah, when I do this one, I'm setting this argument without sending a bang through the object. And I know it won't update here. It won't change. That still looks like 17, but it's actually 22. Now, when I change this one attached to the hot inlet, then the calculation will take place. Neat. Okay. How interesting. Now, I want to do one more thing, and then we're going to actually make some sounds. Let's talk about if statements. I started to talk about these a little bit in my words of encouragement video. If you watch till the end, it was not mandatory to use in your assignments, of course not. But I was just kind of doing a sneak preview for some of the operators. You know, when you think about it, like, what do you think a logic operator is? What does a logic operator mean? Well, I have a question. Have we already used a logic operator in Max? There was one that was in disguise. There was one that was testing incoming messages and then sending a bang if the message matched it. And it had a name, started with an S. It was select. Select was basically, wasn't using logical language, but it was operating that way, that it was discerning, is this the message coming through? Either yes or no. If it is the message coming through, send a 1. If it's not the message coming through, send a 0, don't do anything, right? Now, we have tools at our disposal to be a little more discreet about this and say if, by the way, when I'm saying discreet, I don't mean like private, I mean like definite, the other spelling of discrete. So just to be clear, so we can do if. I made an object and I put if. Now, let's go into the if help. So I'm hitting, this is right click for y'all, and I go open if help. And then we start to see some information here. I think I talked about this exact help thing in the video. But let's do conditional options. And I'll make this bigger. So this is a situation where when I send the number in, it's evaluating, is it greater than 0? So $, variable. In our computer land right now, $, is going to be variable, right? Yeah, question.
How'd you get to if help?
Yeah, I made an object called if. It turned sandy color because I don't have an argument, so it's not going to work. But I can still open the help. I right click it. For me, that's a double click on my trackpad. That's like 2 fingers. And then I hit open if help. And then I'm in here. Yeah. And then I clicked on conditional options because there's tabs up here. So this is a way that we can make, if this is true, then send it through. What does $I1 really mean? It's variable integer 1. The 1 is not, the 1 is the input. The 1 is just declaring it's the first one. And if that's greater than 0, then send it through. Send that through output 1. Does that make sense? Okay. We're going to make some of these in a second. Have no fear. Here's another one. If variable 1 is greater than 0, then send a 1, else send a 0. Okay, so I'm going to increase this. And look, it sends at 1 because that is true. That has been satisfied. This integer is definitely bigger than 0, so we're going to send a 1. If I go below 0, at 0 or below 0, it's going to send a 0. You might be wondering to yourself, when would I use this? Well, something like this is a way to evaluate data and then make it do something else. Let's say we have, let's say we're bringing in temperature data from NOAA, rest in peace. Let's say that we're bringing in like temperature data. Like what's the temperature in Seattle? If the temperature is above 50, make this musical note. If the temperature is below 50, which it frequently is, make this other musical note or don't do anything. Might seem a little obtuse, but if you hook that up to a Raspberry Pi that also has a thermal detector, you could actually make a situation where you're assessing the temperature in the space out here, right? and then making a sound installation based on the environmental atmospheric conditions locally. That's a for instance. But we're doing this to evaluate the numbers and evaluate and make a situation with them. Whew. Okay, we're almost to the fun part. Thank you for hanging in there. Thanks for hanging in there. Yep, this is basically just saying if variable 1 is greater than 0, then send it out through that one, that outlet 1. Else, out 2, send that number through here. So when the number goes below there, it goes out the other side. Down here we have multiple conditions. The double line is standing for or. So if either of these are true, okay, if 1 is greater than 0, it's non-zero. That's true. And if it's less than 0, it's non-zero. No kidding. You don't say. They're both, yeah. If either one is true, it's going to send the message, then send non-zero, else send the text 0. What condition would send the text 0? Zero. Because that's what it's evaluating for. One more thing, and by the way, I'm recording this as a video, so you can review this on your own. You should. Let's also do EXPR. Go back to the main patch and make an object called EXPR. And then right click or double click. Yeah. All right. We're having a good time. So this is how you can literally write mathematical expressions and then have them be evaluated. This one, I'm really glad they put these comments in here. So bang or leftmost inlet triggers the calculation, and an inlet is created for each argument. Nice. Someone let Cycling74 know there's a typo. Someone send them an email. An argument. That's great. There's actually little jokes embedded in these sometimes, especially for the older objects. There's an object called MIDI message, and if you click on the help, there's a comment like down at the very bottom that says, who wants a MIDI massage? Just like the G.I. Joe video. Who wants a body massage? Anybody? No? Okay. It's classic internet lore from the just after Y2K. Okay. Anyway, I'm old. So if I set these arguments, let's see what we got. Let's make this easy, because I'm like, this isn't doing anything for me. So, what do you think when I hit the bang? What do you think the outlet will be here? So, this is evaluating just from left to right. Nope, never mind. It was doing PEMDAS. I'm a silly goose. Forget it. Forget what I said. Lies, filthy lies. There are other languages. I'm mixing up another language. There are text languages that just evaluate left to right that don't do PEMDAS. This one does. Great. So check it out. PEMDAS. Do I remember what this is? Will someone explain it, please? Yes, there we go. Parentheses, exponents, multiplication, division, addition, subtraction. In that order. And yeah, so if you didn't do PEMDAS, this would have created what? If you read it left to right, it would have created what? It would have sent 50. But Max is going to do a solid and do the PEMDAS. And then, so we got 6 times 5, which is 30, plus 4, which was 34. Neat. Yay! It's going to bother me all day. What language was I thinking of? There's another one that doesn't do that. It's gonna bother me all day. Maybe it was like maybe it was in Super Collider or something. Anyway, there's more information. Set does not trigger the calculation. List does trigger it. Okay, great. That's fine. The part I really care about, though, is down here with more operators. Now, we were doing very simple calculations by just sending integers through objects that did one discrete calculation. But what if they do other calculations? So here's one where it's a kind of another step right now, right? To be, okay, input 1 plus 10. This would just be like literally plus 10. Right. That's extra text. Why are we doing extra text? Well, what if I dress this up, right? I'm gonna put extra seasoning on this fried chicken, and I'm gonna make it 2. Now notice, I just lost my Wi-Fi. Go away. Yeah, thank you. VPN always. Okay, so now I added. You can change things in the tutorials, by the way. There are patches you can unlock and lock and unlock, but don't save them, please. When you close them, don't save over it. So I just added another input, and now this is something that the add object could not do, because the add object just wants one discrete argument. Oh, bro, stop. Hold on, I'm gonna connect. You know what? Just, I don't know why. Just Salt Lake City. Okay, VPN, dirty soda, here we go. Yeah, thank you. Okay. How annoying. So, now I can evaluate 2 things in here. You can see how there's added complexity now. Now you could join 2 values that might be changing according to random numbers. They might be affecting one another through other mathematical operations down the line and then circling back. You could create a chaos machine pretty quickly. You could even just send counters, but then have the upper limit of the counter be randomly, stochastically generated by a random number generator. I hope you're starting to think creatively about how you can like make some unexpected calculations this way. Okay, neat. These are all the same. We've basically done these, and you could actually add additional complexity to them like I have. Now these are for comparison. We don't have to use if then. We can just have it evaluated as a mathematical expression, whether it's true or not. Yep, that is greater than 10. Nope, not greater than 10. See what I'm saying? Nifty. It goes the other way too with the less than. This is important. This is a computer jargon here. If you want to test for if something equals something, it has to be 2 equal signs. One won't do it. It wants 2. This is for not equals. Less than or equals looks like an arrow, etc. We're going to play around with these, don't worry. And then here's my logical operators. And. They put a comment here. Both must be true. So what's a number that's greater than 10 and less than 20? 15. Yeah. But I do have a preference for prime numbers. I'll just put 15 though. That's the one I heard. Yes, it's true. 11 is true. 17 is true. 19 is true. What about 4? Not true. No. I feel like it's like a 3rd grade math class. No. Anyway, okay, but this is the syntax. This is why I care about this. This is the syntax for this. is that we have this evaluator, and two ampersands is the logical operator checking that they're both true. This one is either can be true. Yep. A number greater than 10 or a number less than 0. So these integers from 1 to 10 don't do anything. But if I go below 0, it sends a 1, it sends a bang, it sends a go, it sends a yes, right? Brutal. This is a logical not operator. So notice this might be familiar to you. We're using these parentheses to encapsulate this expression. This expression is the one just from before, which said that either can be true. So this one is a number greater than 10 or a number less than 0. But then, just like Borat, we have not at the beginning here, right? So, oh man, I'm so old. It's gonna happen to you. Just like Grandpa Simpson said, one day it'll happen to you. And that's just negating it. Well, let's find out what that means. Well, yeah. It takes the exact same statement and just flips it. Make sense? Does that make sense? Okay. And then that's what we have for that section. You can go and continue reading if you want to with this stuff. We're not going to do that right now, though. We're not going to. No, not today. Not right now. But it exists, and it can do it. Yeah, we'll play with the bitwise stuff later. Okay, great. So that was the portion of my lecture. Notice I'm hitting don't save for the tutorial because I don't want to save the changes I made to it. Please don't save the changes to it. This was part of our lecture today about mathematical operators in Max, because what we're dealing with is data and sonifying data. Maybe we can play with one of these. I'm going to move these out of the way. I'm going to keep them, but I'm just going to scoot them over here. And I want to talk about something completely different now. Well, completely different? I don't know about that. Kind of different. So, again, we've been playing with MIDI. MIDI is how do I say this? It's going to be treated differently than like digital audio. So let's make a digital audio out, and we're going to kind of work backwards because I want to explain these objects. Live.gain. Let me make this bigger. Make live.gain. Are there other ones you could use? Yes, there are, but I like this one because it's perfect. It's beautiful. And then I'm going to create a new object called EasyDAC tilde, and it'll autocomplete. Make sure it's DAC. DAC. Now, for comparison, I'm also going to create, this is just for the lecture. You don't have to do this. I'm doing this. I'm also creating ADC, and it has like a little microphone symbol. What do you think ADC and DAC stand for? Huh? No, it was a good attempt. Okay, so we have digital. Let's hang on to that, digital. And one might think audio. One might think audio, right? But not audio. Different word. Think about this. Your MP3 player, right? I'm old enough to remember the first generation of iPods, right? Actually, I had a Creative brand MP3 player that looked like a CD player, and it could hold, I think it could hold like 100 megabytes of data. Whew. Classic. Okay, that was a big deal. Anyway, that's digital. Yeah, what's up? I made a new object, and I typed easy, DAC, and or ADC. And now the question that's still hanging in the air is, when someone says, oh, it's not digital, it's analog. Analog, there we go. Okay, so this is what this stands for, is that this EZDAC is digital to analog converter. And the ADC is analog to digital converter. The analog to digital will take sound into the computer, make it into a digitized language that the computer can process and understand, right? I use the term loosely. And then the DAC, digital to analog, is going to convert it into an audible kind of output, audible to us. Well, I could send it to an amplifier. I could send it to something that's going to make sound. See what I'm saying? Okay. Might not make a ton of sense just yet, but it will. It will. So I'm going to connect my live gain object. I'm going to take the furthest most left two outlets and connect them to these two inlets. If you scroll over them, you'll see, yeah, there is a start stop command it accepts, but this is audio out channel 1, audio out channel 2. I don't need this microphone right now, so I'm going to get rid of it. All right, cool. What's up?
What was the name for the live game?
It's live gain.
Oh, it's live game.
Yeah. Okay. That's cool. Now, if I turn it on, I lock the patcher, I click this, I can slide this around, but there's no sound, there's nothing going in there to this object, so it's not going to do anything yet. Not yet. So, what's the best way for us to do this? I know. Let's go back to our terminal. And I'm just going to make a sound file in the... I'm going to make a sound file in just like the default voice. Okay. So, what would be a good text? Does anyone have an inspirational quote? Life is like, do you want life is like soup? Like soup. And I am a fork. I am fork. Let's hear it.
Life is like soup and I am fork.
Okay, great. So there it is. We'll use that one. That'd be great. Now, is there a way that the terminal can make a sound file for us? It can. Let's go man say. Again, my does not have to do with gender, but my inner gender scholar is like, but hey, look at this part. Options. There's a lot in here. By the way, I'm also a computer nerd, and so I spent a lot of time reading the manual pages. And so I'm used to scrolling through this stuff. If this is new to you, it's okay if it's a little baffling at first. What this is saying, remember how when we added this option -V for voice, it gave us additional options, that parameters that we could change. When I go down here, this is the one we want. This one is going to be -O. And now what I want to do is I want to output this. We're going to have to play with the paths a little bit. I will be helpful, and if it doesn't work for you for whatever reason on your end, I'll show you an alternative to this. But I'm going to do that previous command, which I don't need to type again. I can just hit up because it's stored, it's cached in there. So I'm just hitting my up arrow. There it is, up arrow. And I have that file.
Life is like soup and I am fork.
But I'm going to do say output and then a path. The path, I already know what the path is for my computer. It's going to be this. It's going to be desktop, and then I'm going to name the file soup.aiff. And then the text. Life is like soup and I am fork. Let's see if we're successful. I saw a new file appear. Now wait a minute. Now hold on a second. We'll have to figure out what the path is. I want to see if this. I don't think it'll behave this way I will help you all with this. But here's my, by the way, here's my file.
Life is like soup and I am fork.
Okay. All right, check it out. Okay. I'm gonna give you the option. I'm gonna show you how to do this, and if it's a little baffling to you, that's okay. I'll give you another option you can use that's actually a lot easier, but this is the cool way to do it. So notice the path that worked for me was users / my name, because I know the name, my username on this computer, and then / desktop. Here, I'm gonna write this in bigger text. So bigger text, the path that I did, and this will be true for you too, is users / your login name. How do you find your login name? You can go to Finder, Macintosh, hard drive, and then it's going to have users. Yours might look different than mine with the big icons maybe, but you hit users, and then you're going to see the users in there. And you want to make sure you're using that username that's you, that your name, right? And my username is Charlie Ruth Welty, right? And then, so I'm gonna put just my name, and then I'm gonna put / desktop. Does capitalization matter? Yes. Yes. Get wrecked. It does. And then a name, and then I'm just gonna put, this is a sample, soup1.aiff. If you put that, the whole chain will look like this. You'll have say-o, this text, and then whatever. You put those into the terminal, and it'll make the file. I'm going to do it again for demonstration purposes. I've literally been in the ocean with wild dolphins, and it's amazing. It's amazing, dude. Bruh. Okay. Yes, I was on the surf team. Okay, so I'm gonna make another file. Say output file users Charlie Ruth Welty, that's me, / desktop. Make sure your spelling is right. And then hold the line .aiff, hold the line, love is not always on time. Aha, it made the file.
Hold the line, love is not always on time.
There you go. Okay, if that's working for you, congratulations. If it's not, we also have sound files that we can use in Max, which I'll show you how to do. But what if I bring in, that file? So here I have my file. You can literally drag it, because we asked it to put it on the desktop. You could put it wherever you want. Desktop is really easy because it's right there. And you can drag it into your Max patch. That's right. Drag it into the Max patch. Boom. And it makes a playlist object automatically. I'm going to bring this down here. I'm going to plug in the playlist object to LiveGain. I'm going to turn on the sound. I'm going to turn this down a little bit so I don't know how loud it's going to be really.
Hold the line, love is not always on time.
Aha, I need to send my audio out. Forgive me. There.
Hold the line, love is not always on time.
Cool. It plays it. Yay! Woo! Okay, big deal, right? That was a lot of work for... But wait a minute. What you don't know yet is we can do some wacky stuff. So what if I loop it?
Love is not, love is not, love is not, love is not, not.
with the patcher locked, I can click in here and I can drag around a part I want to loop. So I could put it like right here. It's gonna loop it. But wait, there's more. If you click on your file and hit inspector, by the way, if you had trouble with the terminal thing, I want to add this. Sorry, I haven't forgotten you. In Macs, there are default sounds, which may not be as cool as this one, but you go over here to audio, and where did they put it? Sample collection. God, there used to be more. Where do they put those? Images. Did they change something on me? Dude. No, they didn't change anything. So there's some in MSP. I'm going to put jongly. So I clicked on audio over here, a little waveform. And then in here, you can pick one of these. I like Cherokee. And I'm going to hook Cherokee up to my system and then loop it. If you're not getting your audio out through the big speakers, what you can do is go to options. Remember this is very important. Options, audio status, and then in here, you're going to change the output device to M-Track, which is the little box, little digital box, which is connected to the system. And it should work. Some of these are misbehaving. I need to troubleshoot some things in here. But, yeah. Okay, cool. Now, save this for reference in your brain. Save this in your mind. If I open the inspector, that's the I, and I scroll down to time stretching, and I turn on time stretching, I can do some weird stuff with this. By the way, what's that popping that's happening? Does anyone know already? What's that popping that's happening? It sounds like clipping. Doesn't it sound like clipping? This does not auto-detect zero crossings. The heck does that mean? Well, you can see that the waveform, part of it, is represented here, right? A zero crossing is where the waveform crosses at unity, where there's nothing. There's just silence. There's nothing there, and then wave and blah, blah, blah. If you cut the audio somewhere that's not the zero crossing at unity, you get the pop. We're going to see this more when we get into DAW land. Question?
Yeah. How did you get the yellow?
I lock the patch and then click on in the waveform.
Line love is not always on. Line love is not always on. 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 Love is not always on.
Oh man.
Is not always on.
There we go. I got the zero crossing. Yay, no pop. Okay, so let me turn this down so we don't go nuts. But so I go to the inspector and I select this thing, turn on the time stretching, and then I'm playing with the speed and the time stretching. Yeah, dude. Notice that if the speed is below 0, it plays backwards. Are there satanic messages played backwards? That's in the inspector. Now wait, it's gonna get crazier, man. It's gonna get even crazier because I haven't told you about something that's actually really cool and really important. I've withheld this information. Did you know maybe you already knew this, that the people who produce Ableton, well, Cycling 74 is like part of that organization. And so we have Ableton devices. But they're going to look a little different than if you use Ableton Live. But they're going to be a tiny bit more interesting because we can actually play with numbers. Okay, here, I'll stop talking. I'll just show you. So, new object, abl.device, and it brought up echo first. Great. Let's echo. abl.device.echo tilde. And what do you think abl.device.echo is going to do? Hypothesis? Huh? Any guesses? No guesses? I'm going to plug this left and right channel into the device and then go out to the little mixer guy, little mixer dog right here. Could it be Satan? Okay, so the echo device is creating echoes. Yeah. Yeah. Okay, so how do we change the parameters in abl.device.echo? Well, let's go to the help. Let's see what the help says. Hey, look. The help has... That you guys heard that, right? Okay. So the help has a demonstration where we can play a sound file and then change these things, your feedback, delay, etc., etc. Notice whatever these boxes are. I'm going to tell you what they are. Whatever these boxes are, you can plug them into the first inlet and then make a change. The way you can tell if you're like, what's this object? I've never seen it in my life. Unlock the patcher, click on it, and it's going to tell you right here. The bottom. And that's hard to read. I'm sorry it's so small. This is attribute user interface. ATTRUI. I'll just call them attruis. So check it out. I'll go back to my main patcher. Attrui. Boom. And then I'm going to plug this in right here. And now, sick. I can change all of these things. Dude, I want the stereo width to be massive. Let's change repitch. Nah, it's not gonna have an effect right now. I want more delay times. Yeah. Okay. So, I know, I'm sorry. It's a little weird. Okay. So, you see where we're going with this? The objects, and this is what I like so much. This is what I like so much. You might say, Dr. Welty, how can I do that in Ableton Live? Okay, but can you make a random number generator that's going to send values into this feedback thing to change the values in real time? Maybe it changes different parameters in real time. 400. Random, and for the feedback, let's do let's do 1 like that. It's gonna send it out to a float. I need a toggle. And then a random, and then there. Let's see what happens in there. Yeah, look at that. It's changing the feedback value in real time. Get wrecked. Oh yeah, I turned it down. Yeah, DJ Dr. Dubs. Okay. That's a for instance. What if you made it so that random numbers were being sent into a mathematical expression, and then when you hit the bang button, whatever's in there gets sent through at that moment? We have ways to manipulate these things at a granular level. Now, we're nearly out of time, and there's so much more I want to talk about, but it won't happen right now. I want to talk about this, and some of this is going to have to wait till next week. I made an object called Pict Slider. Pict, P-I-C-T slider. Pict Slider. And when you click on it and you hold, it does this. Neat. And down here, I'm going to go a little quick, guys. I'm sorry. I'm going to go a little fast because I want to get this idea. We'll pick up with this next time and do more detail on this. I attached integers to the bottom of it. They're like little feet. and then I slide this around and it sends numerical values. I could change the available values in the inspector for the picked slider. By default, right, we have 128 values. Who would have thought? Right? That's pretty cool. That's pretty neat. Now, what if I send that into, I know. Let's send it into a pack object and then make note. Oops, no, I don't need pack for that. I'm sorry, I'm getting ahead of myself. I send it into make note. Remember our make note? And then I send it to note out. And now we're in MIDI land. This is just MIDI. This is just MIDI. And let's see. Great. Well, we already know about that. But get ready. Get ready. It's gonna rock your world, dude. It's gonna change everything. I'm gonna put here pack. I'm gonna put here MIDI format, and I'm gonna put VST tilde. And I already have one on here. Let's use Discovery Pro. It's already on my computer. Won't work on yours. Not right now. Won't work on yours. Discovery Pro. Boom. I have a synthesizer, an external synthesizer that's hooked up to this. Let's do pack. You can actually just watch right now. Just hang out. Pack, sending it to MIDI format. I'm going to send MIDI format out to the VST. I'm going to send this to a live gain of its own that's separate from the other one. And then I'm going to make an easy DAC. Yay! Send it there. Send it there. Nope. Other one. Ah! Get ready. There's a magic trick that's coming. Let's see if it wants to play ball. In this case, it's triggering a loop, right? It's triggering a loop. I'll turn it down. Now, wait a minute. I promised you a magic trick, didn't I? Your computers don't have cameras, but this laptop does. As you can see, I'm recording. So what if I go to system settings and then I go to, check this out, dude. I'm gonna go to, I'm sorry, the Southern California thing slips right in. Yeah, bro. Head pointer and alternate pointer actions. And so now I can move my cursor with my head. No hands, no hands. And then because I have, move that out of the way. That's right. I'm gonna actually control it. I'm gonna click by scrunching my face, by scrunching my nose, and I'm gonna click and drag by sticking my tongue out. So, oh, I have to lock the patcher. Silly me. Lock it. Okay, it's locked. Oh, damn you. There we go. See my tongue, please. Okay. So, by the way, I just want to point this out, and you can also just take over with the mouse again. If you're in music therapy, massive accessibility advantages here. If you have someone who can't use their digits, we already have built-in features to help folks control the cursor with their face and their nose and things. And you can literally make an instrument for them. You could make an instrument for people who are like, I'm not a musician, right? Which, like, everyone says that, and I'm tired of hearing it. But, like, everyone's a musician, everyone's capable. But you can make it so, like, oh, I pressed a button and I did a thing and it made a cool sound, and now I'm a musician. Oh, now you're a musician. Yes. So, see what I'm saying? I might concoct a very simple assignment for us next week, just so we're staying in contact with this. I mean, very simple, because there's still stuff I want to talk about today. I might make a little math assignment. That's really easy. That's all. We went slightly over time. Thank you. That's all for today. I will see you next week. Be on the lookout for a very simple assignment that I will make a video to help walk you through. Anyway, goodbye.